Hello everyone, welcome to Xylene Verilog Tutorial 10. Today I am going to design single port RAM having synchronous read and write. So this is the programming for that, now in which clock signal is applied, address is given, you have to select the data, you have to enter the data, then chip select, read write enable and output enable. Different parameters are there, that is data width 8 bit, address bit 8 bit, and where the RAM address is equal to 1, and that is less than address width obviously. Now as an input parameter, that is clock address, that is 7 minus 1 7 gem 0 means 8 bit address, and chip select, read write enable and output enable pin. There is one another parameter in out parameter, that is data width minus 1 gem 0 means 7 gem 0 8 bit data, that is input as well as output. Now different registers are there. First register is data width minus 1 data out, and second is data width minus 1 gem 0 means 8 bit memory having location 0 to 7 bit means 256 locations in the memory. And one other register is output enable register. Now you have to first assign data when chip select is equal to 1, output enable is equal to 1, and read write enable is equal to 0. At that time data out is equal to this high impedance value, high impedance state. And now in the memory write section, first we have to select write enable is equal to 1 and chip select is equal to 1. That whenever clock is occur, at that time chip select is equal to 1 and write enable is equal to 1. At that time this data, whatever this data, will write into the memory at this address. Now when in the read block, read write enable is equal to 0, output enable should be 1, and chip select is equal to 1. At that time when clock occur, at the time when chip select is equal to 1, read write enable is equal to 0, and output enable is equal to 1. At that time, what is data out? The data out is equal to whatever data in the memory at this address. That should be the output data. And at that time, output enable register should be 1, else output enable register should be 0. So this is the programming for single port RAM having synchronous read and write option. So we have to first synthesize this to check whether there is error or not. So there is no any error. So this is synthesized completely. Now to check the programming, we have to simulation. Let's select this and simulate behavioral model. Okay. Now we have to give the clock, that is 10 and 225 megahertz means for 40,000 picosecond. Okay, we have to first give the address, the post constant, initial address, then chip select should be 1. For writing this, we have to first enable write option, then output enable should be it should be a 0, and then what is data you want to write, that is, let's say 1110. Okay, this data we have to write in the memory location. Okay, fine. So run this. Okay, so uh, this is the address, memory address, and this is the data. So you can see that in the first memory location the data is written. Okay, if I change the address, is constant, that is 000, second position, second address of a memory, and I change the data, that is force constant 10101010. Fine. So simulate again, and you can see that in the second location data is written here. Now second cycle, read cycle. For reading this you have to disable this read write enable, that is that should be 0, and output enable should be 1 for read cycle, and we can read this location address, second location of a memory, and the data in the second location will be at the data out. So, see that you can see in the data out the data is of second location of a memory. If I change the address, initial address, then what will be the data out? The data out is changes to this value, this data 40 and 4.